So welcome here to this session about transport mechanism in GWT. The reason for me being here presenting this is probably related to the fact that about 2.5 years ago, between the 4th and the 5th day as a Vaadin employee, during that night I invented and prototyped the communication mechanism that ended up in Vaadin 7. And then somehow someone got the impression that I know something about communication. Well, we'll see about that. So this session will, as an example, we'll have this like contact class that we in different ways try to send between the client and the server. We can imagine that we're like making an address book application or something. So it's really important to somehow get this data going back and forth. And just to show some cases here, it has like some really simple primitive types there. We have a collection of many types or of many values of the same time. And then to make things even more interesting, we also use this like sub-bean inside this class. Of course, this class also has like getters and setters, and I will generally like skip lots of code that is not really relevant. So don't blame me if this wouldn't compile or something, because it's just like to show the principles here. So when we're talking about communication, we are usually having this concept called Ajax. It has been along for a very long time. I will very briefly go through what it's about. So the middle part there, JA, it's of course Java that you all know, and here we will be using GWT. The X there is for a XML HTTP request, which is the foundation for all kind of communication from the browser. So I might assume that most of you know this, but I will still repeat it. So this is the API that has been around for maybe 10 years almost, that lets browsers send stuff to the server without actually reloading the page. And almost everything that has to do with communication uses this API. So the good parts with this, actually it is implemented in GWT as well. You can use it if you want to. It's good because it's really the standard, at least from the browser's point of view, and it works in all browsers, no problems almost. There are some small tweaks, but it's even so that the GWT implementation of this interface takes care of those differences. The problem, of course, is that this is a very low-level API. There's things like ready state changes that you need to take care of. You need to know that, oh, ready state 4, that means that now we actually have a response. And you generally don't want to do this, but it's still usually there behind the scenes for you. Instead, GWT has something that is called request builder, which is, well, it's really the workhorse of all these things. It's a slightly higher level API above the low level XHR standard, and it just works. It's slightly low level, but it's still not like really bare metal things. And according to you, the GWT survey, about 11% thinks that this is the way to go. So it's like quite popular, but not like the rock star of this. The last part of Ajax is asynchronous, because we don't want to keep the UI in the browser locked while we are waiting for the server to respond, because especially if there's a bad network connection, you can wait for quite a long time. So everything has to be done asynchronously. So as an example of like what this means, I have a really simple request builder API example here. So the first thing to notice is that it's HTTP here. We say that this is a GET request. We could use a POST request or something else instead. And the second thing to notice is that we have to manually define that what is the URL to which we are sending this request. So when you're using request builder, you need to somehow take care of this yourself. Next thing is that we're actually sending the request. So there we give some request data, that's a string, and then we also give a callback that will be called eventually when a response is received. And then we get to this part when, yes, okay, we get the response and we are still like in HTTP land, so we get the status code and then also the like text of whatever the server has sent to us. And then also one slightly annoying part of this request builder API is that you need to take care of exceptions in two different ways. There's this like synchronous things if you screw up something like how you actually use the API, and then there it was, yes. And there's this like asynchronous thing that only happens like if there was a problem with what came from the server, for instance, if there's a timeout or something like that. But those are still like, it's manageable. But the biggest problem with everything that is like as low level as request builder is that, hey, I have a contact object. Request builder wants a string and it gives me a string back. So I would need some way to like go between strings and contact objects, for instance. So this is of course the way you can do it. You just like build that string by taking part after part after part and comma in between, and then you have your data, and then you just split it there, and if it contains a comma you have some problems. So let's not go there. Instead we can use one of several predefined formats, or we could invent our own format. But let's look at what we have like already existing. So we have this thing called XML. It's really popular, I've heard. And well, here we have some kind of example of what this contact object could look like when sent as XML. And since XML is only like a way of structuring your data, but you still need to yourself define like, do I put this as an attribute or as contents of a tag and so on. So you have lots of freedom there still, even though you're using like the standard. And then if you want to do something with the XML data, you could use something that looks like this. So here we first like, well, this is slightly awkward. We have to take care of some documents and find elements there, and well, it's not really that good, I think. And then also here when we want to get the date of or year of birth there from the XML, that's a string because XML only knows about strings. So then we also need to like manually parse it to an integer. And the last part here, when we are iterating through the email addresses, we also like the child of that addresses tag could be anything, and we just have to cast or assume by casting it that, yeah, this is actually a child element, not just a text node, for instance. So all in all, the good part with XML is definitely that this is really standard. Everyone knows how to use XML. There are lots of libraries out there that are using or processing XML in lots of different ways. But there's also a couple of bad points here. One that I showed you, that the code for directly manipulating the XML is quite boilerplatey, and also the actual data that is sent is quite long. There's lots of like things that are not really related to the actual data you want to send. This is in part because XML is really not designed as a like data interchange format. It's instead meant as a document description format, so that's why it's not really that perfect fit, although it still works quite well. And then also one thing that in GWT land, in the like browser, your client-side code, there's not actually that many that good libraries for doing this, because they are instead using something else that we'll come to really soon. And also, as you saw, it's not really type safe, because XML basically only knows about strings and like tags, and that's all. So instead, what's much more popular with GWT is JSON, which is as I also assume most of you know, it's really a subset of JavaScript. So this is valid JavaScript, but all valid JavaScript is not valid JSON. So this would just like become a JavaScript object when we ask the browser to parse this string. And if we once again look at the really basic way of doing this, we have something that is very similar to the XML example. We have this, because this is like slightly more type safe, but not all the way. So we get like a JSON value, and then we need to know or check that, well, is this a JSON object, is it a JSON array, JSON number, JSON string, JSON boolean, and so on. So that also makes this API slightly boilerplate to use. And then also because all JSON numbers are doubles, like as we see them in Java, this also means that if you, for instance, has an integer as I have here for the year, then you also need to like explicitly cast that one. But it's still, it's good. It's standard as well, especially on the web. And here we actually have like GWT really likes working with JSON. There's lots of different libraries for it, and both for directly using JSON and also most of the like other communication methods where you don't need to care anything about what's going on, what's being sent. It still uses JSON under the hood. And the reason for this is mainly that JSON is really fast to parse in the browser, because the browser provides like a natively implemented JavaScript method for this. So just give it a string and almost instantly you get JavaScript object back. So you don't need to like write JavaScript, or the JavaScript runtime does not need to like parse those strings in interpreted code, but instead it's like all the way native code. And also the data format, it's very compact. You don't waste many bytes for defining the structure. It's all your data, as long as your data is not too verbose. Bad parts with, well, kind of JSON per se, and also the JSON example, or JSON parsing example I showed, is that it's still quite verbose. You have like many lines and boilerplate and all those kind of things, and it's still not like fully type safe, although it's getting there. So what could we do about this? One thing that could be done is, at least in GWT, that we see that, hey, we get a JavaScript object. Why not use the GWT way of directly interacting with these JavaScript objects? So then we get something that looks like this. This is a JavaScript overlay that like, it's your Java code that directly interacts with that underlying JavaScript object. Some details about this code. First is that we have this quite interesting syntax here. This is used just to make the Java compiler happy, because what's inside that block, it's not Java, it's JavaScript. So therefore we have to like trick the compiler that it's a comment, although we actually like have meaningful things inside there. And then the other thing I want to show is that this is really JavaScript. This is like, that's not valid Java in any way. I could have just written the other way of doing this in JavaScript, like just this.name, but then it would have looked exactly the same as if it were Java. But now like, this is JavaScript, and you can do lots of JavaScript things here if you want to, although in this kind of case you probably don't want. And the last thing here is that this address sub bean that we have can then also be like defined as a separate JavaScript object, and then you just return that one, then and everything works. So all in all, this way of sending and receiving JSON it's really efficient. We don't have to do any copying of any data. It's just like we get something back from the browser's native API, and we use that straight away. And also like the code is very compact. It was not like many lines of code there. A couple of problems here, because all solutions have problems, I promise you. The syntax is not fully natural. You get used to it, but it's still takes some time getting used to. And also, when you have defined your, in this case, the contact class in this way, you can't use it directly on the server, but instead you need to like have separate representations and keep those in sync. So if you rename a field on one side, you also need to make the same, remember to make the same change on the other side. So let's go a little bit back and see like, okay, we have like a couple of options for JSON now running in the browser, but what do we have on the server here to like match this up? One option is to use something like jax-rs, so you like define your REST endpoints and everything just works as long as you have the same data format, or like as long as both parts agree on how the JSON should be interpreted. I won't go much into this because this is just like standard server-side Java, nothing special there. I will also just for the like example mention that we have this org.json Java implementation. It's kind of the reference implementation of JSON for Java. It's also there for really standard, and it's also quite low level. You have full control of exactly what goes there. But then we also have the same drawbacks that, yeah, this is low level. It's quite verbose code. This org.json library is not suitable for running in the browser because it doesn't utilize the native JSON parsing that the browser already provides for us. And then just a small detail that the license of this library is really free, except that it says that you can't use the software for evil. And that's obviously a problem for someone. For instance, it's not this library, but another library that has the same license because it's by the same author. So IBM wanted to use it, and they asked the author that, hey, could we get a different license because this is like a too broad requirement, you can't live up to that. And then the authors answered that, yes, of course, now you have permission to use this for evil as well. So let's continue with another way of doing JSON. Now we're getting to like advanced stuff here. So there are actually a couple of different libraries for the server that lets you just like say, we have something that takes care of the JSON handling, and then just one line says that, hey, here's some JSON, I want to make it into a contact class object, and the library takes care of everything else. So by default, it just like uses the names of the different properties there, and then you can also use things like annotations in that contact class if you want to customize how it's used. So Jackson is one example of this. Actually, Jackson has quite ugly exception handling, just like that, but you can live with that. But the interesting thing here is that here we are, or not we, but Jackson is using reflection to know that, oh, we should like, or this class has these properties, and then we get something out of the JSON, and then we should like somehow use reflection also to put that back into that object. And as we all know, reflection is not directly usable in GWT, because then that would require all the code to be included. The compiler would have no chance of knowing what parts of the code that should be discarded. So instead, with GWT, we have to use code generation if we want to do things like by magic. And actually, there is this gwt-jackson library that was actually mentioned also during the keynote today, that then lets you like use the same standard for, or convention for how different kind of objects are made into JSON, so that it's fully compatible with the server-side Jackson library. Here we first need to define this like interface. This is just for telling the GWT compiler, or actually like the code generator that runs with the GWT compiler, that this contact object is a class for which we should generate code that like does reflection-ish things. And then we use GWT.create to actually get an instance of this interface, and it's a generic interface, so now it's this instance is bound to a contact object, and then we just like one-liner to actually read it. All these other like surrounding things you only need to define once in your application, and then anytime you want to get a contact out of a JSON string, you just use that one line, and hopefully everything works. So all in all, Jackson, there are also other libraries, although Jackson seems to be the one with the best GWT support for this kind of approach. So here you have very little boilerplate, especially if you abstract away that slightly ugly exception handling on the server. And then also now you can use the same contact class both on the server and on the client if you want to. The problem here is that, okay, now we have achieved that, like, yeah, we have a really neat way of sending objects back and forth. But the problem is that, well, we're just sending like dumb objects. They don't know anything about anything. They're just like blobs of data that we pass. We might want to have something more like sophisticated, because objects are not everything. One way of getting somewhere else is that instead of having a concrete Java class, we just have an interface that defines like what's the data that we want to send. It could look something like this. So here we have like set name, get name, and really standard stuff. And then we ask the frameworks on both sides to actually like create a concrete instance of this interface, and then that gets like hooked up to the JSON parsing and everything. And as you all might have guessed, this is also something that is actually included in GWT. It's called AutoBean. Here's some example code about how AutoBeans work. The first thing we do here is once again that we have this like interface which uses some generic stuff just so that the compiler can know that this is stuff that should be serialized and deserialized. And then when we actually want to use this, we create this like factory object that can create an instance of this AutoBean that knows something about this contact, and then also get the actual like some kind of instance of the contact interface that can interact with, which we do there in the middle. And then we can just get a JSON string out of that, or the other way around. We have a JSON string, and then we just tell the framework that, hey, could you please give me an implementation, a concrete object that implements this interface, and then you get that. So AutoBeans, you can use them just like that, but they also provide a foundation for doing lots of other interesting things, because interfaces are easier to work with from a like technical point of view, because you just have like methods that are called no magic, like fields that the Java runtime or the GWT compiler can't do that much about, because they are more like dynamic or something. We'll get into that. One drawback, of course, is that now we have to use interfaces. That might be a good thing, or it might be a bad thing. It depends on how you want to structure your application. But now when we have these interfaces, we can, as I said, do some interesting things. We can, for instance, use some AutoBean features to actually like intercept invocations to methods of these objects. So now we can do so, instead of just like having set name, get name, we can also do like RPC kind of things, so that we just call this method and then we implement some interceptor for that method, which like causes some actual something to be sent directly to the server instead of just getting out a JSON string that we send ourselves. Another thing that we can do, for instance, is that now we can provide, like, once again, intercept equals and hash code methods of these interfaces, and use those to actually make sure that like the same object, even though it's different instances, those are actually like from Java's point of view equal. This is really important quite soon. And then also one thing that we can easily do, it could be done with other techniques as well, but this one makes it really easy. We can make it so that, for instance, if you have called, only if you have called set name of this like object instance, only then we actually need to send that value back. So in this way the underlying communication framework can know which parts have actually changed and which do not need to be sent over the wire again. And for these kinds of concepts, GWT has this thing called request factory. This is really based on having like entities. This is something that maps almost directly to, for instance, JPA entities. So this concept requires quite much setting up, but once you have it set up, it's quite smooth to use. So the first part of setting it up is to define this like interface that once again just like defines what kind of types we want to work with. And here actually we have another step. We also have like that part of what we are doing that is actually doing something with the contact class, because our like request factory could have 10 different request types that it also deals with, but here we just have one. And also this contact class, aside from like managing contacts in a generic way, you can also define specific methods for contacts. For instance, here like list all the contacts, or then also to like take this one client-side contact instance and update it to the server so that you can run some specific code on the server to like store it in the database or something. One thing we also see here is that here we have this contact class, but that's only used on the server, and then we also have these like contact proxies, usually what it's called. So this is just an interface that looks similar to the AutoBeans interface that I've had shown previously. And then the last part, we need to once again use GWT.create to hook, or to get the generated code produced by the compiler, and then also hook this up with its event bus. And then when we actually want to use this, we have something that looks like this. First, here we want to like get all those contacts from the server. What we do is that we get an instance of this contact request that we previously defined, and then we just like call this getContacts method, which returns this like, let's go back there, this request object. And then also, because this request factory framework assumes that by default you only want like that actual object, you don't want any like descendants or subbeans or anything. So here we can like define that yes, I want this one, but if there would have been some other sub part of this object or this class, we keep that out because it's data that's only needed on the server or only needed in some other context or something. So here we get really like control over what is fetched in, even though all the serialization is done completely without outside of our control. And then we, of course, once again have like asynchronous fetching, so that we just define a callback that gets called with the actual data once it has arrived. And then, let's say we have received this data, we show it in the UI, the user wants to edit something, starts editing, and then when we actually have edited the contact proxy instance, we then, again from this request object, do an update using this instance, and then we just fire away that request. On the server, we now have like, well, this could actually also have this entity annotation there and so on to show that this is really like, this is a pure server-side object. It's designed to live in your database, be processed by JPA and so on, or whatever framework you want to use. But still, it should also have all these name field setters, getters, and all those kind of things, but I leave those out here. But there's also some other things needed. The first one is Second one is all these need to have IDs, an ID and a version. This is something that you also get by default from, for instance, JPA. This is then used, ID is used to like do this identity thing so that two contact proxies that you have received in different ways but are actually the same object. So these are actually considered to be the same entity. And the version is used, for instance, for like knowing from the server that has this object been changed since the last time we sent it to the client. And then if it hasn't been, if it still has the same version, we can know that we don't need to actually send the data. We just say that, hey, it's the same object that you already saw. And then here inside this contact class, we can also implement those like service methods that we defined. So here we have this update implementation that was using the instance request. So it's actually like run on a specific instance of the contact class. And then also we have this non-instance request, just a normal request, which then is a static method that does something. Here we now again get this problem that we need to keep like this contact class and those definitions in the interface in sync, so that if you like want to rename update to update me or something, you need to remember to do that in two places. To slightly help you here, the GWT framework provides an annotation processor, something that like is run by your IDE every time the IDE compiles your code when you have made changes, and that one will then also like tell you whenever something is missing. So you get lots of like red lines everywhere in, for instance, Eclipse, if you don't have all these things in sync and set up correctly. So, all in all, Request Factory, this is a big framework. It has lots of functionality. I have just like shown you slightly about what the concept is about. It's really designed for entity kind of data, where you have like strong identity that you want to keep track of and persist somewhere, probably somewhere else than in your browser. One big benefit here also is that these entities, their implementation do not have to be compatible with GWT, so you can use whatever you want actually in those classes, but still have like almost transparent mapping to the client. Another good thing here is that yes, we can like get these data objects sent back and forth, but the same framework also gives a way of doing like RPC kind of communication, so that we actually like more like sending messages and less sending data. Drawbacks of this is that it's quite complex to set up. You might even get slightly scared if you look, for instance, through the tutorial on the official GWT web page, because it's quite long. It looks quite scary. Another thing here that we now get into, and we'll continue exploring that, is that now we are really tightly coupled with the server. We need to have the thing that's running in the browser and the thing that's running on the server to really be in sync, and also like we are limited to having Java on the server with all these like just doing whatever JSON you want. You could have even a PHP server if you want to, and everything would just work, and that would then maybe be convenient if you also want to have, say, an iOS front end for your application. But now here with Request Factory, it gets quite tricky to get iOS code that reads, native iOS code that understands the format that is used for sending things over the net. So, according to you, about 7% of you are using this, so it's about the same, slightly less than just the like really simple request builder, but it's still not very much. So now we'll continue exploring what we can do. Now we have like we have had these like some kind of objects that we have made into JSON strings, sent those. We have had interfaces defining the data we want to send, and then get those going back and forth. Yet another thing that we can do is that we just take like Java objects and send them in some way, straight off without like thinking in any way of how they are sent. So the trivial way of doing this is of course that we have this like send objects method that gets a bunch of objects and gives you back a bunch of objects. This is slightly problematic. The first problem is of course that it's not type safe. The next problem is that the GWT compiler also needs some hints because it can't really include support for including or for understanding any kind of object that the server could send to you because there's like too many of those. So instead what we need to do in some way or another is that we once again define an interface that says that these are the things that I actually want to send. This is how I want to send them. So here we are again only limiting ourselves to like contact, classes, lists, and actually only list that contains contact classes. So now the GWT compiler is once again happy. It knows that it's a very limited set of classes it needs to support. It's not the entire world. This does, however, still have a slight problem because here this is what you would want to use, maybe, because it keeps your code really nice. But the problem here is that we still have the asynchronous model to take into account. So we need to somehow make it so that the runtime does not wait there for the list of contacts to actually be available. We just want to give control back to the browser, and then when the data is available, we get notified, and then we can use that data. So there's two kind of ways of getting there. One is that instead of actually returning, oh, there I have a bug I see now. We should not return async result of contact, but instead list of contact. But ignore that one. But still, like, we return something that is like asynchronously giving us the actual object, the data we want. So then we get that back immediately, and then we can add a listener to that gets notified. And then also once again using generic so that we have type safety here. So we can make a listener that knows that, hey, I will get a list of contacts. I will not just get any object. Another way of doing this is to instead have like two different interfaces so that instead of just, here I have more typos. Who have made my slides? This second async callback should of course again get a list of contacts and not just void. But still, the point being that we have this like asynchronous version of this interface that aside from the actual parameter we want to send, we also give it the callback that we will then use to get notified when the data is available. And actually this second part here should look quite familiar to, I guess, most of you who have read anything about GWT tutorials or something like that, because this is exactly how GWT RPC is designed. So this is really a simple concept to grasp. There's just like you define the interface and then objects go back and forth, and usually everything works. The only slight problem there is that you have like two versions of your interface that you need to keep in sync, but they're also like IDEs and Maven plugins and everything make those parts quite easy for you. Another thing here is that this is really like the default solution in GWT. If you once again open the official GWT documentation and look through it, this is the first thing you see about communication. So it's a proven concept, and it's quite easy to use. One, because we always need to find drawbacks here. One drawback is of course that you are now once again have to make the data you send has to be compatible with the GWT compiler, so you can't use all those features that are not available in the browser. That's maybe a problem, maybe not, but let's ignore that problem because there are other solutions that I have already presented. Another problem here, or maybe a problem, maybe not, it once again depends on your use case, is that you are basically sending everything, everything that the object you actually pass to this RPC method. So all those objects referenced by that directly or indirectly are also sent, unless you do some special tricks to just send parts of it. But still, like, you send an entire object graph, which might be what you want, it might be exactly what you not want. So that's something that you might need to keep in mind also. But still, this is the thing that most of you seem to use, at least most of you who answered to the survey. So I guess it's good. This stuff uses some things like checksums of all those fields or all those class definitions, so that it can know that yes, we actually have the same implementation on the server and on the client, because once again these are heavily coupled. Actually the Recast factory also does similar things. Another thing that now we are getting into, like, security problems maybe here, because the client can say to the server that, hey, create this object, and it could be really any object unless you restrict it. So here we have so that the GWT compiler sees that, okay, these are the objects that you have actually defined that you want to send, and then the server side sees that, okay, the thing that comes from the client is actually on this list, so it's safe to create this object because it's really something you want. One third interesting, like, implementation detail here is how the data is sent, because there's completely different, or not completely different, but slightly different formats going from the server and to the server, and this is all, of course, to make things as efficient as possible. So going from the client to the server, we have, like, or actually one step back. The basic concept overall is that we have, like, a pool of strings that we then can reference, so that if the same, like, data, because all data is eventually either a string or some primitive number. So if the same string is included several times, then we have this string pool and just, like, reference to it. So yeah, let's get that string number 2 back again and again and again. Another feature, or actually what we see here in the beginning, is what's going from the client to the server. So first we say that, hey, we have 2 numbers in the string pool, then we get those 2 actual strings, and then there in between we would get some additional, like, metadata and such, but I'm ignoring that part. Then we get, like, 42, that could be just like a number, that number 2 also. But then also if, oh no, actually that 2 is a reference to the string pool, because we are, like, sending also, like, this is the method, this is the interface and the method that we are invoking now. Then the server side that receives this can see that, okay, this method has these parameters, so it knows directly that, okay, then we should process the next data item based on the assumption that it's, like, that data. So it always knows what the next item should be. And then we can also, for instance, have, like, this -4 here represents that. It says that this is, like, the 4th previous object that we also got. No, actually it's the 4th object that got sent. So that if like, the same object instance is sent multiple times, because you have, like, a big list that contains duplicates or something, then also this format takes care of, like, just referencing back to that previously serialized object instead of sending it again. But still, this is what's sent to the server, and then the server sends something like, it contains the same data, but it's, like, different order and everything, and different format. So here we again see JSON, almost, because some browsers don't like really big arrays, so we actually, like, we need to process this in a slightly different way if it's complex, but you can pretend it's JSON. Then we again get this, like, string pool, and then here everything goes backwards because that's more efficient in the browser. We just get this big JavaScript array, and then we just like pop things from the end going until we reach the actual end of the array. So that's why things are sent backwards going in this direction. So that was basically all I was going to say about GWT RPC. Now we can get into some really interesting concepts here, turning the world around and so on. So the first thing we could do is that so far we have only had like, the client says that, hey, I need some data. The client says that, hey, I update this data in the database because it has been changed by the user. But what if we instead turn this all the way around so that it's the server that is like in control of the communication. The server says to the client that do this, do that. And then the client just says like, okay, here you go, and now the user did that, what do you want to do about it? So then, instead of like having data or something, we have this, it's really state-based in some way, probably, maybe. Actually, we'll just go here, because we have like, on both sides, we can pretend that the blue one is the client side and the green one is the server side. So we have like some representation of what we are doing. This is getting really abstract, but communication is often abstract. So we have some kind of state, and then probably if we have like a server that is controlled, it has like the same representation somehow, the same hierarchy of things, both in the browser and on the server. And then these can like talk to each other instead of like going all the way around, like having this central endpoint that everything goes through. Like we have this jax-rs service definition or something like that. Instead, we can like have direct communication, because this would not be possible if we wouldn't also have similar state on the server. But if we have this, then we can go like directly from one part to the other part. So with this state, we have this shared state, which is good. The problem we can get here is that we want to keep this in sync, because things can happen on both sides, and that gets complicated. The easy solution is to say that no, we don't take care of any synchronization. We just say that, hey, it's the server that is in control. It's only the server that can actually modify the state. The client side can just like react to it, and everything is fine in that way. We get rid of lots of complex things with conflict management and so on. But then we still also need some other way of communicating things back from the client. So for that, we need some way of sending events. And well, another way of looking at events is to say that it's like RPC calls in one way or another. So code to look at this could be, once again, this is client-side code. We need some way to tell the server, or tell the GWT compiler that what are the types that should be like handled by this. So we could, for instance, have this like getState method that says that, oh, this is once again a typo. Yeah, contact state should be there, of course. That says that this is the state type that we want the GWT compiler to generate support to. And then we get like this state change event, and then we can just see like, well, has this property changed, has that property changed inside this state, and then we just like use that straight of, for instance, pass the name to our widget that does something with contacts. Yeah, that was what we did there. Or then we could have like RPC. We define an interface. Once again, here we could, for instance, also make things simple, say that we don't ever return values. If we want to send a value back again, you do another RPC in the other direction and keep track of those things manually. So then we just like get this proxy type or an implementation of the RPC interface and just call something on it. And then correspondingly on the server, we just like register a concrete implementation of this interface and do whatever we want when that is called. And this is how the communication in Vaadin happened to be implemented. So we have this real stateful server that lets you do things in a completely different way. It's up to you whether it makes sense or not. Another thing that Vaadin provides is push support, which Arthur demonstrated to you this morning. That's not per se something that is particular to this model, although once again, because we have the server in control, there's more of a need for the server to actually send things back to the client instead of just having the client asking for stuff. The bad thing with this model is the same thing as the good thing. You need to have this stateful server. You need to have a Java server. You can get quite big states that you might or might not see as a problem. And according to the survey, once again, 6% of you are using this for your code. The final thing I have for you is that we completely get rid of the idea of communication. We just like say that, hey, does it really matter? It could be that something is happening locally. It could be that it's going over the wire to some remote place. We don't care. It's like, why should we care? So now we get to this Erai framework that was presented before lunch here. So here we could, for instance, just say that, hey, we use CDI, and we just like send CDI events. So we inject this event, we fire it from the server on the client, doesn't matter where we are, and just standard CDI stuff. And then everywhere where we have this like observer, we just get that event as long as it's in the same scope, and it just works. Great. So this is just a small part of the Erai framework, just as the communication was just a small part of the Vaadin frameworks. For both these, there's like tons of other stuff that you also get at the same time. So I would probably say that don't use any of these just for the communication, but instead like look at all the benefits, and then you also get neat ways of communication, like for free. So here we have completely transparent communication. You don't need to care in any way about what's on the server and what's on the client. Erai bus also provides like different ways of communication. By default, everything just works out of the box, but if you want, you can also use this like REST endpoints instead. And then also the Erai implementation does automatically provide this same kind of server push support. The one bad thing I want to mention here is that here we have, once again, it's transparent, which means that you might accidentally send more things that you want to send. Of course, with Erai as well, there's this mechanism for defining that these are the classes that can be sent over the wire. But still, if you have like this class that contains some things that normal users should use, and then some special data that only the admin user should see or something, because you still store all that data in the database. So then you would still like, it might come as a surprise for you that, hey, oh, this admin data is also sent to all these like non-admin users, although they don't see it, but they could still like reverse engineer it if they want to. So that could be a small problem. So the end thing here is, which one should I use? I don't know. It's all up to you. I have tried to give you an overview of like what are the ideas behind these and what are like their good and bad parts, and then I guess it's all up to you. So I guess I could ask for some questions, but I'm also afraid I'm quite low on time, and Joni there, who will have the next presentation, is looking quite nervous, but one small question I can have.
So having worked with a pub-sub client-server bus system, one of the downsides was that when you're looking at it from an action perspective, because you're trying to save something, you have to implement your own timeout.
Your own what?
Your own timeout.
Timeout.
Since it's a send and pray model, you don't actually know whether the server actually ever got it. That means that you have to do an item code.
Yeah, so the comment was, in case you didn't hear that when you're sending something, for instance, you want to update something from the client, then you also need the complexity of knowing that the server can acknowledge that yes, now we have actually processed this, so that the client can say that, for instance, show to the user that yes, it was really successful. So this adds some complexity to something that, in my quite trivial example, was really simple. So yeah, that's a good point. And okay, one last question, just because it's you who are asking.
So the Erai, you showed both Vaadin and Erai, they're both putting the server in charge.
Yep.
What's the trade-off in finding the server has to do something?
Yeah, so the question is that what's the trade-off of putting all these or performance trade-off of loading the server, all this state, all these other things that Erai and Vaadin does. I don't know. There is of course some overhead there, but it's usually not a problem in the kind of projects I have seen. Thank you.